My name's Steve Mather. I'm going to talk today about OpenDroneMap. By show of hands, who has seen this presentation in the last 2 years? Yay. All right. Good. I mean, it's grown, it's been augmented, but actually some variation on this intro was actually presented in CGIS 2 years ago, so I was feeling a little guilty. I've been a few places talking about and deploying OpenDroneMap. Actually, one of these places I have not done anything with OpenDroneMap, but starting with Seoul, and then a few places in Europe, and then actually I have not done anything with ODM in Rwanda. That's a lie. And then most recently in India and the Middle East. And one of the things that I like to think about is like, what's the future of mobility? Like, what's the future of mobility of data collection? What's the future of mobility of cargo and mobility of people? It's sort of out of scope for what I do, but I like to think about that in the context of open data, open hardware, and free and open source software. So a little homage to Paul Ramsay. If you know Paul is one of the founders of the Postprocessing project. I'm going to start with a little bit of a diversion. Who's seen this picture? Okay, good. So this was posted on Reddit. A gentleman suggested that this was his mother and that she had painted this picture and that she wasn't sure if she liked it. It was her second painting, and he was looking for praise from Redditors to give back to his mother. I'm not sure what this guy was thinking. It was not the approach that I would take to encourage my mother to paint more. But, you know, the response was interesting. So this guy painted a picture of the woman who painted the picture of the, I don't know if that's an egret, and posted it on Reddit in response. Okay, that's funny. It didn't stop because it didn't. It kept going for a while, and then someone did try to close the loop, which was an impressive effort. I'm pretty sure that was just done in Photoshop or something, but nonetheless, much appreciated the sense of humor there. And I think we can safely say that this is very meta. So here's the reality is they didn't close the loop. This is the whole tree, starting with the woman who painted the egret. That her son then posted on Reddit to get praise, and the man who painted the picture of the woman who painted the egret. And then we saw this woman, and then this gentleman, and then the egret holding the whole series. But as you can see, there's, there's 20 leaves and 44 total variations. So it's something else. And this is, I think, something that only happens in a few places. Sometimes weird stuff like this happens in large cities, right? But usually weird things like this happen on the internet. So, you know, commonly known as CommonsBased peer production, and a term coined by Harvard Law professor Benkler. And the equation is, if we take people and we combine them with free or inexpensive tools, and we connect them with a common purpose, common love, or in the case of the example I gave, maybe it was an obsession, not a love. You know, maybe just different. You know, there are different definitions of love, I guess. Results in something strange. Sometimes that something strange is really, really useful. We think of Wikipedia, right? OpenStreetMap, GNU, or its better known sibling, Linux. And in the vehicle world, also Shahidi is a good example. In the vehicle world, this framework applies to all sorts of things. As far as free and open source software, I don't know if you all caught it, but last year Toyota started running all their Camrys on Linux, and Tesla's running on Linux, and Audi, Mercedes-Benz, and Hyundai are all in this consortium. There's some interesting things going on. Other examples of some interesting sort of facilitated CommonsBased peer production, check out MapSwipe. This is world changing. You want to help map people around the world, and you want to do it while you're waiting for the bus. This is a really great tool. And in drones in general, we've got open source flight controllers. So we've got ArduPilot, and one of the projects that ArduPilot helped birth, if somewhat painfully, PX4. So today I'm going to talk about OpenDroneMap. So this is really about processing of imagery. Since I am in a state that has rules about who can make photogrammetric data, I will start with the caveat this time that follow your local laws with respect to using these tools. In Ohio, we can get away with all sorts of stuff. It was funny. I got in trouble the first time I presented OpenDroneMap with some folks here in North Carolina, and then I was all excited. I was presenting in South Africa, and I was all excited to present, and then they actually have very similar rules, very similar laws that have recently been passed, and there were a lot of certified photogrammetrists in the room, and I was in trouble all over again. So this is a tool. Who uses it, how it gets used, and how it gets certified is all dependent upon context and legality. And I always want to be honest about the purpose of OpenDroneMap. This is really in preparation for the robot takeover. I mean, who doesn't want to report to this group? Actually, these are kind of cute, especially compared to, say, like a Tesla. We don't know what the future looks like, right? It might look something like this. It might look like this. Some days it feels like that's likely. This looks like the present, but with flying cars. But we know that folks in Silicon Valley and elsewhere are really interested in this question of the future of mobility. What does it look like when we create self-driving cars? What affordances does that give us? How does that change how we interact with the world? And yeah, there's nothing terrifying about that at all. That's not a bad deal. Anyway, regardless, we know that the future includes data. It includes better real-time data and better relatively static data. And OpenDroneMap's meant to be an open source toolkit for that to help more people generate these data. And it's modern photogrammetry, fully automated. And I used to say it's a toolkit, not a platform. But now we've got a good caveat. There's actually some folks who have deployed it as a platform, including some of our core contributors. So the origins are in computer vision and photogrammetry. And for me, the purposes are ecological, humanitarian, and really about open source data. By way of just explanation, I am Mennonite, which really complicates my robot narrative. But Google image search helps tie that back together. If you search for robot Amish, this is one of the top listings. It's really the only useful one too. The rest are kind of disturbing. So what do you get with OpenDroneMap? So one of the primary products, or one of the intermediate products that you get with OpenDroneMap is you get a dense point cloud. So if you fly with lots of overlap with the drones, then all the matches between the parts and pieces become this dense point cloud. This is a mountain in southern South Korea that's seen some die-off of, it's basically as a result of climate change. The National Park Service, Korean National Park Service, has seen die-off of some species, and they're trying to document and understand that better. And this is one of their data sets. Another intermediate product that you get is a textured mesh, and this is really just something pretty to play with. I don't know how many people actually use this, but it's a lot of fun. And then texture mesh is nice, but really a lot of times what we really want is that ortho photo, something that we can measure on and do quantitative work on. And then we have 2.5-dimensional products like digital surface model, digital terrain model, etc. And those are heavily in production right now. So we've made a lot of progress in the quality of the ortho photos in the last year. And in the last few weeks to months, we're making some really great progress on digital surface models and digital terrain models from OpenDroneMap. So you might be asking some important questions at this point. I mean, I led with the question of the robot takeover. So I'm guessing that there's at least a few of you who are saying, this is great, but how do I get started on collecting the necessary data sets for the robot takeover? And thank you for asking that. Let's talk about how to use OpenDroneMap. So if you go to OpenDroneMap.org, you get these options. You can use the command line version, ODM. You can use WebODM. You can use NodeODM. You can use LiveODM. You can use CloudODM. You can use PyODM. I did a presentation a few weeks back, and I was like, okay, let's help navigate this. All right, let's take a screenshot of the main web page. Oh dear. Which do you use when? So I came up with this little diagram. So ODM is the core. This is sort of what does the processing. If you like command line applications, ODM is your friend. But maybe you don't like command line applications, or you really need to access it through a web interface for whatever reason. It's a remote server, and you want to upload that data through the web rather than through some sort of copying process. You might use NodeODM. But you might actually want multiple users and security and other nice little things, so then you can wrap around that WebODM. And then if you just want to boot off a jump drive on your laptop or on another machine, you can use LiveODM. And just for the sake of complexity, we also have CloudODM and PyODM. Okay, so I haven't made anything any clearer. This is a lot of choices. And this is one of the sort of blessings and challenges of an open source project, is things can evolve really quickly, and you get lots and lots of choices. So I created a decision tree. And the first question in how to decide which one of these to use is, am I a robot? If you're a robot, you probably want to use PyODM. All right, that's a nice Python API that you can interact with. This also might be something if you want to write a plugin for QGIS or ArcGIS to process imagery. PyODM would be the way you would do it. Say, well, no, I'm not a robot. I'm a nerd. Okay, you got a couple choices. You can use ODM if you want to run it as a local resource, and your local resources are adequate. Or if you want to run it on the cloud and you want just a command line application that'll run it on the cloud, CloudODM is the really great tool for that and a lot of fun to use. But maybe you're not a nerd. For this room, anyway, maybe you're not a nerd. So in that case, LiveODM or WebODM is probably what you want to use. Frankly, these are great management applications as well. So it's not just about nerdiness; it's about usability and context. So if you've got a lot of flights, a lot of different teams you're working with, or you're just trying to manage and view the data quickly, WebODM is a great option. So in summary, robot, nerd, non-nerd, those are your options. So that actually doesn't, core to this is really that node ODM piece. That's the glue that allows us to do all the sort of interesting things in different contexts, and because it's an open ecosystem of tools. So I said that there's a platform, Piero Tofanin, who's the founder of WebODM and a core contributor to OpenDroneMap in general, has actually started a pretty cool service called WebODM.net. I told him he has a branding issue. WebODM.net doesn't actually run WebODM, but I suppose he'll work on this. I have no financial interest in this project other than when Piero gets paid, then he writes code for OpenDroneMap. So actually, I guess I do have an interest in this. But this is a really inexpensive way if you don't own your own really large server. And you want to be really efficient about deploying and reusing rented resources. This is a pretty inexpensive way to process data, and the machine gets destroyed in the background. You don't have to worry about it. You don't have to manage any of that. You just download the data and use it locally. So, okay. So I've got 4 minutes and 45 seconds to talk about the future. Funding. First of all, we started at Cleveland Metro Parks. We've gotten funding from American Red Cross, the Humanitarian Innovation Fund, Global Facility for Disaster Reduction and Recovery, World Bank Tanzania have just funded a round. We had a kickoff meeting yesterday to start working on some really cool stuff, and I'll show you where we're going with that. Maserano Labs, which is Piero Tofanin, has done a lot of in-kind work, and then Dakota Benjamin, who's now with Humanitarian OpenStreetMap, has done some in-kind work. So recent developments. So we've added some interesting things. So you want to be able to process the data, and you want to be able to share it easily. One of the cool things that got added in the last 9 months, maybe 6 months, is direct OpenStreetMap digitizing. So you process your data, you're ready to go. This is all in WebODM. And there's just a little button to then take that out to OSM and start digitizing and adding to that data set. And then say you want to share your data with the world and you don't want to point them to your server all the time. OpenDroneMap is a great resource for open aerial data for the world. And you can push those data, you can push your data that you process in ODM right to OpenDroneMap just with the addition of an OAM key. We've seen some really cool serverless cloud deployment work by Maserana Labs. We've been working recently to improve the point cloud, so I'll show you what we've done, what we did in the last 6 months and what we're doing in the next 3 months. And then we've done some really substantial improvements to the orthophoto. So by way of comparison to closed source software, we've got Agisoft PhotoScan, Pix4D, two of the giants. We've got the previous OpenDroneMap point cloud, which was embarrassing, and then the current one, which is less embarrassing. I like less embarrassing. Look at that. That's a lot less embarrassing. It's still embarrassing, but I have high standards. And then we've been working...
built from aerial images, and it's actually made out of 4 different...
I don't know how to mute this. So I'm going to talk over how. So one of the problems that we're solving right now is how to scale, how to take really large data sets and split them into smaller data sets, but still maintain matching between those data sets. So that in X, Y, and Z, the final data sets match just about perfectly. And that challenge was taken on initially by Mapillary, who works on the OpenStreetMap, Open Structure from Ocean project, and this is some of their initial results with that. So more to come on that. So once you do that, then you can take a 7,000 plus image data set here from Dar es Salaam in Tanzania, and you can break it up into a bunch of little pieces that can be processed on a small machine. This is cool. So then you can have a relatively modest machine, and as long as you've got time, you can let it process through. And the next stage for this is actually, well, there's lots of next steps for this, but one of those steps is to then actually distribute that actively to a bunch of machines so that you can process it quickly as well. So you could upload this to the cloud, you have 7,000 images, and you say, I want this done in the next hour. Okay, this is the batch size, let's get it done. Each of those pieces, then we have to merge back together. So here's a couple of ortho photos side by side from that split data set. The slide order doesn't make sense, sorry. Hey, we improved the ortho photo. Look, it's better. Still better. Okay, so putting stuff back together, when you split the data up, then we need a way to create seamless reconstruction of that. We'll probably use Grass for that, although initially we were looking at using the existing seam lines in OpenDroneMap to help with that by sort of chopping out the bits that are near the edges so that we get something more like what's on the right than what's on the left. And again, more like what's on the right than what's on the left. Although these are both cheating because we actually moved the seam line completely off the scene. So let's look at one where the seam line is actually in the scene. And it looks pretty good. Then our 2.5 dimensional data, we need to be able to merge that together. Again, I think Grass is going to help quite a bit with this. And props to Anna Petrosova for helping us with that. And then we're improving the point clouds even further because, as I said, I'm still embarrassed by them. Blast. Now over by 3 seconds. So we're improving the elevation models as well. And then in the future, we need to look at the question of what's the post-processing look like? What are the additional things we can do? And be nice. Okay. Do I have time for questions? Did that include time for questions? Ha. All right. And who doesn't want these folks in charge? Not a bad idea at all. Yeah.
If you were going to do that 7,000 images,
yeah,
and stitch it on a 1/16 machine,
how long would it take? Okay, so the question was, if you were going to process 7,000 images on a 16 gig machine, how long would it take? And the answer is, I will have an answer 30 days from now, upon my deadline. Because that's the first deadline. Actually, it might be more like 60 days as far as the deadline for knowing how long it'll take. But we'll have some estimate here in the next few weeks. But I don't have one yet. Yeah.
Is that a memory or a CPU core dependent deadline?
So is that a memory or CPU core dependent deadline? So there's two. So what we've done with splitting the data sets is we've avoided our problem of being memory limited and switched it to a CPU limiting problem.
Okay.
Yep. So basically, just let it run until it's done, and we'll find out how long that takes.
If you have multiple cores in the 16, does that help or not?
Yeah. If you have multiple cores with that 16 gigs, it definitely helps, just as long as your ratio of cores to memory is reasonable. And we have some metrics for that, and we'll be publishing those as well. You had a question?
Yeah, I don't really know much about drones, but I know you're talking about autonomous vehicles at the beginning.
Yeah.
Are drones already autonomous by option, or will it be at some point soon?
So are drones autonomous by option? According to the FAA, drones are not autonomous by option. They are automated, or some other sort of changing word. But yes, they are autonomous. I just press a button and the thing flies. The whole thing. It's wonderful. It just depends on the context and the hardware and the software. But yeah, you can pre-flight plan everything. In fact, you should for doing aerial imagery collection. Yeah.
How much screening do the photogrammetrists do? You said they screened your little bit.
Is anybody here a certified photogrammetrist? Wow, I had so many last time. I don't know. Usually it sort of starts with hey, what are you doing? And then we have a pretty reasonable conversation. So, yeah. I think the conclusion of the conversation that we had at NCGIS a few years ago was, hey, make sure you follow the law. So if that includes bringing in a photogrammetrist or a surveyor and their stamp and their authority to overlook their things, then great. Cool. Appreciate it. Have a good morning.